The drill chuck should be kept clean and free from swarf, with a periodic application of light oil in the mechanism. It must be noted that this type of tool-holding device is designed for straight or parallel shank drills only. Taper shank drills must be inserted either directly into the machine spindle, if they are the same size taper, or into a sleeve adapter, and then into the spindle nose. The same cleanliness requirements apply here as for the taper on the drill chuck. You can also do the same checks for radial runout of the drill. This will ensure that the drill is not bent. Insert the drill into the nose taper and rotate it so that the tang locates in the spindle slot. Place a piece of timber on the machine table, pull down on the operating handle with the drill stationary, and press the point into the timber. This will provide enough axial force to lock the taper. For larger drills, a light tap with a soft mallet onto the point would also serve the same purpose. To remove a drill from the spindle nose, you will need a drill drift, which is placed through the slot at the base of the spindle, straight side to the top. Push it through until contact is made with the drill tang, and give it a smart tap with a hammer to release the taper. Hold the drill with the free hand to ensure it doesn't fall onto the machine bed and cause damage to either drill or machine. When drilling on the center lathe, winding the barrel right back on the tailstock ejects taper shank drills. Some production processes use collets to hold drills. This facilitates a quick change of drill or swap to a reamer. These are very similar in construction to drill chucks and require the same tests and procedures. On basic drilling machines, the work needs to be presented to the center line of the drill, at the location where the hole is required, in order to produce the hole in the desired position. This can be achieved by simply marking out where the hole needs to be, and then manually lining up the drill with the center point, clamping up and drilling. Alternatively, if the machine has lead screw calibrated slides, one can, by calculation, position the center of the drill over the desired coordinates. Another method for use when drilling a number of components would be to initially set the hole position for the first one and then set stops to position further components after that. If it were a job that was repeated often, it may be necessary to use a specially produced jig or fixture to provide set coordinates and a location sleeve to position the drill. The more sophisticated special-purpose drilling machines, such as coordinate machines or computer numerical controlled machines, are programmed to locate the hole coordinates and, if necessary, change the drill to a different size. The other major factor that we need to consider is the work-holding device when assessing the integrity of drilling quality. There are numerous ways of holding the work, from the basic machine vise to sophisticated special-purpose fixtures such as a dividing head or rotary table on a milling machine. But in all cases, there are some basic rules to ensure that the efficiency of the drilling operation is not impaired by the work-holding device. First of all, it must be clean. The flatness and trueness of the machine table must be carried through the holding device. Therefore, the base must be wiped clean, and any locating surface within the device must also be clean. Secondly, it must be rigid and stable. It should then be securely bolted or clamped to the machine table, having aligned the drill point to the hole position. This type of setup then provides a very secure anchorage for the work-holding device. You must also ensure that the workpiece is securely fastened into the vise so that the cutting forces cannot push it out.